So last week we started working on COVID-19 project. So these are the things that we did last time, included the path of the file where we will be retrieving the data. So this data is from John Hopkins University. So this link we have used this data. This is the live. It gets updated every day. So if you look at this particular GitHub repository, so right now it's not. So let me go to this thing. Okay, it's COVID-19. Yeah. COVID-19 time series data analysis. Yeah, you can see here. So this data we have pulled. Okay. So this is the link that we have given, and you can see that this data is updated. So this data last updated 3 hours ago. See, 2 minutes ago. So this is it gets updated every hour, every minute. I think it gets updated. So we are working on this data. So whatever the analysis we do, the number will match with the actual number that we see in wave. Okay. So this was the confirmed case, that case, and the covered case file path that we pulled from this repository link, right? And then we imported that file using read.csv, and we renamed the column from province state to province and country slash region to country, and we did in place equals true so that the changes remains permanently in our data. Then we did transform so that our data was in this format. If you go in CSV view raw, so it was showing up per day wise. Here you can see. So that's why we did a transformation so that we transpose all these rows into column. So once we do the transpose, so if we run this, if you run this here, if you run this, if you look at your confirmed cases now, this has been transformed to one particular date.
Okay.
So this is the date and this is the count. So for transform, we use melt, pd.melt.
Okay.
What we need to transform, these columns will be fixed, and we will transform into date, and new column will be count.
So in the data meld, we use pd.meld to transform and to then we just allocated like ID words is equal to province, country, and latitude.
So yeah, this id verse, what does this means is these things are same, these
Mhm.
things remain same.
Okay.
Okay, and beside this everything will be stored in date field,
Mhm.
and the value will be stored in count field.
Okay.
Okay, so let me show you once again. Mm, so right now, let's say we simply imported our file. Okay, and if you check dot head, so it is in all row. These are all in columns,
Mhm.
right? So what does id bars does is this frame equals data means this data which we have imported right now. Okay, so whatever we pass here will be our data. Okay, so if we passed confirmed cases because this was my data that we have loaded, right? Then we gave frame name as the data that we have loaded, which is confirmed case. Okay, then id was means this field will, these columns will remain constant, 1 2 3 4. and we even have status, because this status I have added. That's why you have status here. Okay, so these things will remain constant. Okay, and remaining all these will be stored in date field. Okay, and the value, this value will be stored in count field. Okay, so to make these four column fixed, we need to store that information in id vars. Okay, and whatever transformation we want, we will store that in date, and the value will be stored in count. Okay, so this makes sense.
Yeah, almost. It's clear.
Yeah. Okay. So this will be my head. Then I have added status here. That's why you have status here. So once we do transformation, and now if you see, all this value has been transformed into one particular date field and column. Column is new column will be your date, and value will be your count. Okay, so same process we will apply for death and recovered cases. That's why we created a function, so that we don't need to repeat this for confirmed cases, for death cases, for the covered cases. That's why we created one function, so that we can do this for death cases as well as for recovered cases. Okay,
Okay.
and then what we did, we merged all this into one.
Mhm.
Okay,
Yeah, with the concat,
yeah,
yeah, authenticated
then
cases.
we did concat. Okay, and then we checked the type,
Mhm.
this which type this particular column is.
Yeah.
And since my date is in object, I need to convert this to date time.
Okay.
That's why I converted this to date time. Now
So
if we look
in the column 25, with this command, you converted date into
into
time. Like,
date, it was not converted into date previously, because it was an object.
hmm,
See here, it was an object format.
yeah.
Then we converted that into date. So what's the difference? Let me show you the difference then.
Just show me like how you converted that into date, like which command you given.
This pd dot to underscore date time,
Total date is equal to pd dot to date
to
time.
dot date
Oh,
time will convert that into
okay.
date. Okay. So if you look at the header dot head, you see here your
Yeah.
date is in 1/22/20. Okay. So if you convert this into proper date time format,
Mhm.
okay, then if you look at your data, then see here. So I have converted this into date, and then I have stored that as my index. So I have set this as index. So this 0, 1, 2, 3, you see this is my index, right? So I have stored my date information in index. That's why you see here. See here, it's in proper date format, right? 2020 01 22. So it is in this date format, proper date format. Okay. So this has been converted into proper date format. Then what we did, why I stored this as an index, so that I can fetch this row easily. So if I do 0, this will give me my first row. Dot index I need to give. Dot index and 0. If I do this, so that I can fetch particular row easily. That's why I set that to an index. Okay. And again, that this 0 means first value.
First
One,
value.
yeah, first row.
Hmm.
One means second row, and so
Second.
on. So if we look at here,
Hmm.
so my data starts from COVID cases starts from 2020 01 22. So from there we have COVID data, right? So I need to look at the latest data, right? So to look at latest data, what I need to do, and look, go into index, and jther will give me first row, and -1 will give me last row, right?
Last. Yeah.
Okay, so I did -1 here so that I can get all my confirmed cases, recovered cases, and date cases here. Okay, so this is the command. So this is to do, this is to get latest data, latest latest cases based on the COVID cases based on date. So if you do a markdown here,
Mm-hmm.
then this will be converted into text. Okay. Latest COVID cases based on date, I did -1. And then what I did is, so I need to compare my latest date with previous date, 1 day minus. So I need to know so that I can build a KPI. So this downward you see here 0.6. This is based on the previous day, right? So this one is on basis of previous day. So I need previous day, right? So to get previous day, what I did is, so what I did is, so if I give set here, set will remove duplicate, right? So I did set first. This will this will remove duplicate. Then I will convert this to list. Okay, and then I did a sorting. I did a sort so that I get data in a sorted format. Okay, so once I get data in a sorted format, I did -2. So -2 will give me, so -1 will give me latest state, -2 will give me previous state, right?
Previous means second last date.
Second last state, yeah. Latest state -1, you can say second last state. So in this way, I got second last state. Okay, this line of code gave me second last state, right? And then this one had latest state because I did a -1 here. This had a latest date, and now this will have latest date -1, right? Latest date -1. So total date, total data confirmed. If we do sum, this will give me all the confirmed date and recovered cases. It will give me sum for all of my cases. So then what I did is I put a KPI. I have shown you how to pull this KPI. You can go in plotly indicator. If you do indicator in Python, here you have an indicator. So by using, you can see here you have lots of KPIs. You can choose any one. I have chosen this KPI. Okay, so I will send you this in Skype for your reference. And then what I did, so here, so title means this title here confirmed came from here. Okay, and I did, this is my value dot sum. This gives me the latest confirmed cases, and my reference means the last confirmed case, latest -1 date. One stays here in reference. So latest -1. This is my latest date, and this is in the reference we gave latest -1 so that we can do a comparison, right? And then we gave here 0 and 0, so that 0 0 means first column, 0 1 means second column, and so on. Okay, So likewise, I gave confirmed cases, recovered cases, and death cases, and I did a comparison. So this gives me this KPI. Okay, this gives me this KPI, and then I have updated my layout. So once you run this, and if you check this in Google, COVID cases worldwide, if you do, so you can see here in worldwide your cases is 166 point something 7, right? So this numbers is matching, right? 3.5 million, 3.45, so approximately. So it's the number is matching. Okay, so I have pulled data from John Hopkins University GitHub page. That's why the number is matching. In that GitHub repository, the information is updated every minute. That's why the information is matching with what we see in web application. Okay, any question here? So you need to try this by yourself. If you go and choose this, if you simply copy this here and paste here and run this, you will see all these graphs are created, right? So here what we need to do is, from here you need to change your value. Okay, so what I changed my value, and my value was, this gives me the latest date, right? So I changed this to latest date. Okay, and my reference, then I added the reference line, this line here. Okay, so simply if you run this, yeah, so this is the KPI. You can see the changes here. Okay, let me make these changes in third one. uh in first one, let's make the changes in first one. I add here reference, and then if I add this text here, and so in this, you can see it has the changes has been made in this speedometer. You can see the changes has been made. If you want to make these changes in here, this is your zeroth row and first column. So you need to copy these changes here, zeroth row, first column. See here, the changes has been made, and you can rename this text if you want. So you can rename this to confirmed, or whatever you want, you can rename. So you can play with this, and you can copy this indicator, and you can make changes, whatever, which one you like. You can add your KPI if you want. If you want to play with this one, simply you can copy this and paste in Jupyter Notebook, and simply try to run and check how this is looking. So if this display looks good to you, you can use this, or you can simply play with these indicators, and you can choose your favorite indicator, and you can add that to Jupyter Notebook. Okay, and then what I did is, then after getting the rough figure of total confirmed, recovered, and death cases, death cases, And then I tried to look for top 10 countries with COVID cases. So to look at top 10 countries, what I did, so I looked for status and sorted by count, so that in descending order, if I sort my count on descending order and take only 10 records head of 10, that will give me the top 10 countries, right? Because I am sorting on the basis of count on descending order, right? So by count descending, and then I only took country and count. Okay. So after taking this information, I got top 10 countries with recovered, confirmed, and death cases. Okay. And then just for visualization, I removed the index, reset the index, just to add the visualization. And then I use this background, style background gradient, so that I can change the color map. So here you see the red. You can change this to blues if you want. You can change this to blues. So yeah, blues, it looks even good than red. So your recovered cases till now on basis of countries. So in India, you can see this much recovered cases. So if you match this with the application, you can see your recovered cases is 23.1 million for India, right? So if you see here, the numbers are matching. Brazil, it's 14.1 million, right? So numbers are matching because we have used John Hopkins Git repository dataset. Okay. So likewise, we did for confirmed cases here. You see confirmed cases, the number will match with wave application 33.1 million, 33.1, and then India 26.3, 26.5. So it's matching closely, 16 million and 16. So it's matching closely. So you can give, you can change this to confirm cases to green if you want. Greens will work or not. No, greens will not work. Let's change the rate. So you can play with this background gradient styles. So you can Google this background gradient styles in Python, and you can choose several. So if you choose Fufu, what will this happen? Okay, see here, you can see the changes, the color. So you can play with any other color if you want. You can go in this, you can go in this website, and you can choose your colors, whichever colors you want. Gradient, Fufu, high, low. Okay, you can do a research more. Okay. And then we displayed. Then I did a bar graph, and I have taken the confirmed cases for the most recent days. That's why I did max. And if we plot this, you can get the recover top 10 recovered cases. So you can see India is on top, followed by Brazil and so on. Then what I did is I want to compare my total recovered cases and confirmed cases side by side. So I did a soft plot here. In soft plot, using a soft plot, you can compare your graph side by side. Okay? So, I added 3 rows and 1 column. 3 rows means this is my first row, second row, third row, and I will only have 1 column. Okay. So if I give here 2 column, then what would happen is first row, first column. first row, second column, second row, first column. So my row will be 2 here. Okay, let's see what this happens. You can see here this 2 is side by side, right? Because why it is side by side? Because here I have given 2 rows and 2 columns. So here, in this is my one row. In one row I have 2 columns. This is my first column, second column. Okay, and this is my second row. Second row, first column. That's why you can see second row, first column here. So we can compare the recovered and confirmed cases side by side and see, in the US 33 million has has COVID cases, confirmed COVID cases, out of which 22 million has been already recovered, right? So in India, we had 27 million COVID cases, confirmed COVID cases, out of which 14 million has been recovered, right? And how many, this green arrow, so green, red, and blue, you can see here the indicator says you which one is confirmed, which one is death, and which one is recovered. Okay, so this much we did last time. Okay, this much we did last time. So
Sorry.
last last time we did a KPI and we plotted 3 bar graph, and today we will continue the same. And today what we will be doing is, so today we will plot, we will draw a map here, where in the map, if you can see here, in near Australia, this is the dot which shows the confirmed cases, right? So if you see here the dot in Australia, you can see near Australia you don't have COVID cases, much COVID cases, but when you scroll your map and you go, you can see here,
Yeah.
yeah, in near India, you can see COVID cases is extremely high, confirmed cases is extremely high here.
Mm.
And even if you go back to more other countries, you can, if you click here in United Kingdom, even you have few COVID cases you have, but the most the highest COVID cases you see near India, right?
Yeah.
Yeah. Okay. So we will plot this today.
The red balls, you mean to say?
Yeah, so the size of the balls, red balls, says the cases, how much COVID cases it is. So the smaller the size, the
This.
less the COVID cases you will have. Okay.
Okay.
So we will plot this today, and then what we will do is, then we will look at weekly, uh, how the COVID case is occurring on a week wise or a day wise. We will analyze that. So I have taken my country, Nepal, and I have seen like, last one week or last 50 days, how is the COVID case is in Nepal. So in last 50 days, you can see the COVID case is increasing. So we will do a visualization for that. So we will plot this, and again we will do a side by side comparison for 4 countries. So we will plot the confirmed cases graph, and we will see the various method how we can plot this graph, even through matplotlib or plotly. We will see all that, and again we will do side by side comparison of 4 countries. So see here, the Nepal and India has the highest COVID cases. You can see here
Yeah.
the COVID case are not the highest. I mean, the trend is increasing in Nepal and India. You can see side by side. In Australia, the COVID cases is consistent, like what it was previously, still it's that much, you can see. So, but the trend in India and Nepal is increasing at a higher rate. Yeah. Uh, so we will plot this graph, and even we will look in worldwide how in worldwide this is for complete world. In the world, how is the COVID cases rising? So the COVID cases, confirmed death and recovered cases, all worldwide, how much it is rising. So we will look that. So we will create this plot today. Okay. Okay. So let's start. So our data is this total data. So it contains all confirmed cases and recovered and death cases. So we need to transpose this data on the basis of confirmed, recovered, and death cases so that we can plot that information in a map. So again, we need to do a pivot here. So for doing a pivot, one issue that we had is in province we have NaN cases, right? So we should not have NaN cases when we do a pivot or transformation. So let's convert this NaN cases to NA. Hardcode this as not available. Yeah. Okay. So
So why we put not applicable in fill NA?
we can put anything, but right now I have given not applicable. We will say not available. It should be like
Not available. And
not
what is
available,
fill NA? What is that?
not available.
No,
NA
the
means
fill NA, fill NA.
fill
Before.
NA means whatever null value you have in your data
Mm-hmm.
that will be filled by NA. So
NA.
here,
Ah, okay, okay.
okay. So this I have explained you when uh, we were studying regarding data frame, all the basic things that we were studying.
No, I know about the thing that we are doing total data and is equal to total data province. I was just confused about the fill NA, like why we put that. So now it's clear.
So then we will do let's do a sum is NA. If we can even do info, if we do info, we can see how many null cases we have in our data. So right now you can see that latitude and longitude you have null value here because total null, not null is this much. You can see here the numbers are less, so we have some null cases here in our data. So let's remove that null cases. So what we'll be doing is dot info will give us whether we have null cases in our data or not. Then we will do drop NA info. Okay, now data looks good. But we right now we simply did drop NA. We can even look why this data is null. First, we need to check that why it is showing up a null value. Okay, right now we didn't check anything. We simply drop that value. But in the real work, we need to look at that data why we are trying to remove or what we need to do. First, we need to analyze that. But right now we are simply dropping that. Okay. But here now let's do transformation. Um, so let's give a new name. Transformed data equals pt dot pivot underscore table bracket. First will be my table name, data frame name, then comma, then index means the thing that needs to be constant. So the table dot index comma province comma country comma latitude comma longitude. So this will be constant, this will remain same, but we need to transform status. So my columns will be status, values will be count, and function will be np dot mean. So we need to import numpy. Now let's check transform data. Okay, so this is been transformed. You see. So previously, what we did? Previously, we use melt. We use melt to convert all our rows to column, right? And then again we used pivot to convert all our columns to row. Okay, you can see. So to convert columns to row, you use pivot. To convert rows to column, we use melt. Okay. So now we have 9 cases here and we covered. Let's fill the 9 cases with NA. Cover equals fill NA to 0. Okay, so this 9 will be converted to 0. Okay, and then we reset our index. Dot reset underscore index. Now let's have a look. Dot. Okay, so now our data looks good. All these 9 cases has also been converted into 0. Okay, now if we look at transform.info, we don't have any missing cases here. We have few missing cases. So we have extra value here. Okay, so some rows are not available for confirmed and death even. So let's try to convert this to, maybe the NaN cases is there for death and confirmed cases. So let's convert all that to NA, to 0. Let's convert is true. So that's why we need to check uh, every time whether we have a missing data or not. Okay, now this looks good. We don't have any non cases. So total entries was this much, and total value is also same. Okay. So in this way, we check whether we have non cases or non cases or not, or missing data or not. Now to draw this map, we use Folium. So what is Folium? Folium, sorry. Uh, if you don't mind me saying. So this Folium, if you Google Folium in Python, so so using Folium, you can draw a geospatial data. That means the map and all whatever you see, all maps. So Folium is a Python library used for visualizing geospatial data. That means all the maps you have, the map is not shown. So here, let me open this in Chrome. Here, even if you see map of cases for last 14 days, here you see here. Cases. If you even if you see here on the right, you can see the size is denoted by the circle, right? So we are trying to replicate this map. So in Python we have Folium. Using Folium we can draw these types of map. This you can see here. So to draw this type of map, we need to use. So these are the styles. We can choose any tiles layer. These are the styles we can choose. So here the title is this one. So we can choose any style that we want. Okay. So these are the maps that we can use. OpenStreetMap. We can use Mapbox. Examples, if you look, you go in this place. Go here. You can see this. These are your styles. So if you use OpenStreetMap, this is the visual that you get. So if you use MapQuest open, this is the visual map you get. So if you need this type of map, you need to use this MapQuest open aerial. So if you use this one, Mapbox Sprite, you get this type of visualization for your map. If you use Mapbox Control Room, you get this type of visualization. Okay, and so on. You can use any sort of any visualization you want. Okay. So I'm sending you this link in Skype so that you can have a look. So in my visualization, I have used Stementarian. So this one I have used. Okay. So so you can see here the titles. You can change this title. So we will check this. Okay. So let's plot this map. So for that we need Folium, Folium, and then map will include Folium, Folium dot map, and then you need to give location. What does location means? So in your example, if you look, so we have this data, right? So so, so what I did was I chose the country. Okay. So let's choose if country equals Australia. Okay. So I chose the latitude and longitude of Australia. Okay. So let's say New South Wales. So whenever my map will be displayed, that time the starting location will be New South Wales. Okay. That's why this is your starting location. So if your map is visible, what would be your starting location? So this will be my starting location whenever my map is visible in Jupyter Notebook. And then I will use zoom underscore start. This means uh, how much zoom you want in your map. Okay. So whenever your map is visible, if I do 4, it will be more, four times zoom will be applied there. So it depends. We will change the zoom start and we will see how our graphs are changing, how our map are changing. So I have used mm, this style. Let's add this style. Okay. So for latitude, longitude, value, name, value, name, and country. In zip, what zip does is zip aggregates all the column. So I want to aggregate zip bracket latitude, which is lat, transform bracket longitude. I'm going to transform bracket, my value will be conformed cases. I want to see conformed cases. That's okay. Comma, transformed bracket. So I want to see country. So your table country, and then I also want to see my province, state. Okay. Province. So I'm looping this so that I can see all the information about several countries. So that's why I'm using a for loop here. So I can iterate all my rows. Okay. So I need to use Folium dot circle. So to have circle, I need to use circle marker. Okay. So circle marker will give me all the circle. Okay. Then bracket. Need to pass my latitude and longitude. So this is the latitude and longitude. So whenever we do a visualization in a map, we need to have latitude and longitude. Okay. So my radius Radius means the size of this circle. So the numbers for confirmed cases are very high. That's why what I do is value divided by uh, for 5 0.1 million. I do division. Then I use pop-up. What does pop-up means is, so if you hover over this information, you get France and total confirmed cases is this much. So whenever you touch here, so you have this information. So to have this information pop up in your map, we can add here pop-up. Okay, so pop-up will give in pop-up what we need is, so we need state information, because in pop-up here you can see the state, then total confirmed cases, we have this much. So if you give here strong means this is a HTML tag. Okay, strong state strong. This is an HTML tag so that the font becomes strong. Like a font is, so if you go in here Google, and if you go strong HTML meaning, you go here, indicates the content has strong importance, seriousness, means your that particular title is highlighted. Okay, you go in here, you can see example here. If you give here strong, this information is bold, right? Strong, if you give a start and end with a strong, means this information is bold. So we are giving strong so that state information is bold. Okay, then we will add name of our state. So will this name is the name of our country. Okay, so we need state name. State name is resides in country. So this lat means this is referring to first field, long is referring to second field. Here this is the second field, the value is referring to third field, and so on. So here I need state information is in last field, province. So last field is, so this is my state information. Okay, so this information I need to pass here, state dot capitalize, so that it's in capital letter, plus br will means the next line. Br means we are moving to next line. Okay, and the next line will again be strong, strong and confirmed cases, slash strong. This time, so this time what I need is, so my confirmed cases resides on, so for second thought, this is the confirmed case, resides on value. So I need to pass this value here. Okay, let me close this, plus str of value plus, let's add one more s, more br means enter. Let's add the enter line there, and then comma color. So color was my read. So let's add blue color. So why I have added blue color? Because in worldwide map, even if you see here, so it is in blue. So let's try to replicate this map. Blue, comma, fill underscore color equals red, comma, fill underscore opacity equals 0.3. Okay, and we need this to add to all this information needs to be added to map, right? So this map. So we don't need to remember all this thing. You can find this thing in Google if you go and look for Folium circle marker. If you do, yeah, you can go here, bubble map. You see here, so you can see here. You can copy this. You have see here the longitude. You can look at this example, and you can replicate here bubbles. See, you can replicate this information. So this we don't need to remember and everything. You can check this for drawing a map. We don't need to remember everything. We can simply look and see what information is being given and how we can replicate that. Okay, so if we run this, so this is taking a bit of time. So we can also save this in HTML file even. So map, if we do map.save and save this in map1.html, let's say, you can save this in HTML even. This is taking a bit of time because the data is huge. That's why it's taking time.
Excuse me, sir. Even can for Mac we can save like with HTML as well.
Yeah, we can save this map in HTML page even. Yeah, that's what I'm trying to show you. So it's taking time. Yeah, it's done. So let's open. This was the even this here. You can see because we did blue and yeah.
This one is more beautiful than the red dots.
So if we do minus, let's zoom out. So why this is showing up? The first page is you can see Australia here because here we